Okay, so boys and girls, today we are learning paper six. How what is the technique for us to score the mark for the paper six? Okay, last week we already talked about Hooke's law. Hooke's law actually is the spring, okay? The spring extent. So F equals to Kx. This is the formula that we learned last week. The X actually is extension. Extension can be in cm or meter. Okay, this one is the load, or we say the force is acting in Newton. Okay, the K actually is a spring constant. So this is the formula that we learned last week. And then spring constant is the value from the value we can know that whether this spring actually is stiff spring or actually is less stiff. Okay, that means that hardness. So if the K value is high, that means this is a stiffer spring. So it's not easy to extend, not easy to extend. Okay, so boys and girls here, okay, this is the some summary in the exam. Okay, so they like to asking you to draw or what is the technique for you to get an accurate reading. Okay, let's say we want to measure this extension. How we measure it? Okay, basically this one we call it a set square. So you have to know set square. We use set square as our horizontal reference. If you use your eyes, maybe you will be slightly slanted. Maybe, okay, we don't know. So maybe you read 12.5, your friend read 12.6. So it will be slightly different. But we're using the set square helping us to get the horizontal reference. Okay, horizontal reference. So this is one of the technique, important technique. Okay, what else is actually you need to make sure your eyes perpendicular to the spring level, but normally I will say perpendicular to the scale of ruler. Okay, I would like to say eyes perpendicular to the scales of ruler to avoid parallax error. Okay, so use set square. Then what else? One more in common answer you can add as D. Okay, one more common answer is you put your ruler nearer to the load. Okay, put your ruler near to your spring. So this diagram actually can be improved by drawing the ruler somewhere here. Okay, somewhere here. Okay, so this is perpendicular. Your eyes perpendicular to the scale of ruler 90 degree. Perpendicular meaning that 90 degree. So normally I will say perpendicular to the scale of ruler. Okay, to avoid parallax error, make sure your eyes perpendicular. Okay, what else? D is here. Okay, you can add number E. Ruler put nearer to the spring. This is one of the technique. Okay, so three technique that are commonly used in paper 6 is we use set square as our horizontal reference, helping us to take the reading correctly. Okay, second, make sure your eyes perpendicular to the ruler to avoid parallax error. One more, okay, ruler close to your spring. Okay, so this diagram can be improved by moving the ruler nearer. Okay, then using the set square. Okay, set square, this part is horizontal. If you say, teacher, can I draw like this? Yes. It's also using the horizontal part. Okay. So if you want to draw like this, can or not? Can. Okay. You want to draw like this, can or not? Can. Okay. But don't draw somewhere here for what? What you want to measure? I don't know. Okay. So this is some summary. Okay. So we look at this. That day I got mentioned to you. Please remember, print it out in actual size is because you are going to measure. IGCSE class is investigate the motion of a mass hanging on the spring. So this is the setup. On the figure 1.1, measure the length LO. Can you measure the length LO from here to here, LO? Okay, can you measure and then you tell me? Measure and tell me what is the answer at here. Zihua, are you correct? Are you print in the actual size? No, lady. Dear. Did you guys print in actual size, Crystal? No, also no. I don't think you print in actual size, dear. Any others answer? Xuan, correct. Xuan, correct. So for this one, if you print in correct actual size, it should be 21 mm. Okay, then be careful. This is mm. Normally, we're using our ruler is showing you 2.1 cm. If you write 2.1 inside this answer, 2.1 mm, this is wrong. Because this is mm, so you need to do conversion to 21 mm. Okay, so Zihua get 21. Crystal, I think you printing problems, but it's okay. You write the correct answer, 21. Okay, the diagram draw 1/10 of actual size. Of course, this is A4 paper. It cannot draw actual size. This is only 1/10 of the actual size. Write down the actual length LO of the unstressed spring in mm. So what is your actual size in our real life? This is just 1/10 of actual size. So what is your actual size? What do you think? How you know? Okay, Zihua say 210 mm. Correct. Okay, so this one is 1/10 of actual size, LO. Okay, what we measure just now, L, small l, is actually only 1/10 of LO. So LO should be 10 times small LO, which is 10 times 21. So 210 mm. Okay, then next. Student hang 300 gram of mass and then we get a new length. It's because when we hang, something hang, so the spring will extend. Okay, it extend to 255 mm. So calculate the extension by using this formula. Actually, in our paper 6 is trying to give us mark. So all the formula they will tell you. So you see, extension is using L. Where is your L? L is here. Where is your LO? LO is here. So they already told you using this minus this. Okay, so 255 minus 210. So you will get 45 mm. Okay, 255 mm minus 210. Okay, until here, is that clear? Okay, calculate a value for the spring constant K. See, they give you the formula, so we just use. Okay, K equals to F over E, where F is 3.0 Newton. You see, they give everything, so we just find 3.0 for the F. E, what is your E? So you need to find where is your E. Just now here is E. So we're using 3.0 divided by 45. Can you guys tell me what is the answer we should write at here? Do calculation and then tell me what is the answer I should write at here. Is it? Let me count. No, Zihua, careless, careless, careless. Crystal, correct. Very good. Unit also correct. Angeline, unit. Tell me the unit. Let me have a look. Emily, careless. I think careless. Angeline, correct. Zihua, correct right now. Okay, so boys and girls here, the answer is 0.067 Newton per mm. Okay, here, or we accept 0.0667 Newton per mm. Okay, so at here, this one is two significant figure. 6, 7 is two significant figure. This one is three significant figure. 1, 2, 3. Okay, can I write 0.07 Newton per mm? My answer is no. This is only one significant figure. Okay, in our IGCSE, we accept with the significant figure is 2 to 3. Okay, 2 to 3. So these two answer correct, but if you write 0.07 Newton per mm is wrong. Okay, then just now, Emily, did you able to get 0.067? Okay, here, what is a unit? You see, this one force is in Newton. The E at here just now you get is in mm. Newton per mm. So this is actually unit Newton per mm. Okay, Emily, is it careless? I think so lah, because just now Zihua also get the same answer as you. Okay, so we goes to your page number 3. Okay, accept 2 to 3 significant figure. Okay, next. The student adjusts the positions of the lower clamp so that the pin is level with the bottom of the mass. Okay, when the mass is not moving, she pulls the mass down a short distance and release so that it will oscillate. Okay, the load will oscillate. Okay, the figure 1.2 show one complete oscillation. This one is related with chapter 1, measuring the time using pendulum, also one complete oscillation. Okay, so this one is going up down lah. Okay, so they tell you go up, go down, come back to original position. This is one complete oscillation. So we are not only taking one complete oscillation because human got reaction time. We cannot react. We cannot react so fast. Okay, we got reaction time error. Okay, so normally we will take 10 to 20, 10 or 20 complete oscillation lah. Okay, so by using this method, we're using a more number of oscillation. Actually, we can reduce the error due to the human reaction lah, because the error is spread out already. Okay, so at here, although I want to know one complete oscillation, what is the time, but I cannot just count like this. I need to count for 20 complete oscillation or 10 lah. Okay, 10 complete oscillation. So this is the time they get. They ask you calculate the time taken for one complete oscillation. Time taken for one complete oscillation is called period. It's called period. Okay, boys and girls, write down period. Okay, so can you count and then tell me 20 complete oscillation is 26.84 seconds. Then how about one complete oscillation? Correct, Crystal. Correct, Zihua. Correct, Angeline. So, you see, 20 complete oscillation is 26.84 seconds. Okay. So, one complete oscillation is how many? Actually, you're using a mathematic to solve it. 20 over 1 equals to 26.84 divided by t. So, your t actually 26.84 divided by 20. Okay. So, let me have a look. Emily, correct. Make it 3 significant figure. Okay, because I think, let me count. 26.84 divided by 20. Okay, 1.3 second also can, but 1.34 second. I will make more accurate 3 significant figure. Okay, let me think. Okay, so next. She replaced the 300-gram mass with 500-gram mass. Okay, so repeat the timing again. So calculate 20 complete oscillation. Can you count if 500-gram mass with this result? What is the time for one complete oscillation? Crystal, correct. Angeline, correct. Zihua, correct. Okay, so you will get 1.72 second. 1.72 second. Okay, so they say that students suggest that time taken for the oscillation for the spring should not be affected by the change in mass. Mass changes, it should not change your period. Okay, whether her results support this suggestion or not. She said that, okay, no matter I using 300 gram or 500 gram, supposedly the time for one complete oscillation should be the same. Did the results support her suggestion? What do you think? Yes or no? Does not support. Because the time taken is shorter. Okay. Does not support is correct. So statement here we say no. Okay. That whether her results support this suggestion or not? No. Okay. Then how we explain? We need to explain that these two value, you see, these two value, their difference is too big, too far from each others. They no need to exactly be the same. Normally, we will say like roughly 10%. Okay, plus minus 10%. So if let's say this one is 1.70 second, 1.70 second at here, let's say, then this one 1.72. Uh, whether this result support the suggestion or not, our answer will be yes. Okay, because their result is quite close to each other's. Okay, but now 1.34 and 1.72, their result is more than 10%. It's too big already. So we must say that no, does not support. So that means that this statement is wrong. It's affected. Okay, so at here, difference for both T is too large, each too far different. Okay, too far different or too large. Okay, their difference is too large. Okay, until here, is that clear? Can I proceed? Okay, so okay, next, explain how you avoid parallax error. How you avoid parallax error? Do you know what is parallax error? Parallax error is the error due to the wrong position of eyes, wrong eyes position. Okay, if let's say this is the spring, okay, we want to measure, we want to have a look about this. So your eyes should be perpendicular, right? But then maybe you look at here because your friend is standing at here, so you cannot see. So you're standing at here and then you look at it. So this is a wrong position. This is a parallax. It will cause a parallax error, or you are here, eyes is here. So this is wrong. Only this perpendicular, this one, only this perpendicular, 90 degree. This is the correct position. How you avoid parallax error? Okay, so make sure your eyes is perpendicular to the ruler scale. Okay, so we write perpendicular viewing of perpendicular of scale of ruler, perpendicular view to the scale of ruler. Okay, so at here you may draw your diagram. If you worry you cannot explain clearly, then we're using what? We're using diagram to show it. Okay, so I will encourage we draw like this, and then this one like this. Okay, next, so at here we can draw our ruler. Okay, we complete. Draw our ruler close to the spring, something like this. Okay, so this is our ruler. Okay, so at here we can put a set square like this. We can draw a set square. Then label set square. Set square is one of the method helping us to avoid the parallax error because it's showing us this is your correct scale. Okay, helping us as a horizontal reference. Okay, so one, perpendicular view. Second, we're using set square. Okay, third, we can mention about ruler. Very close. Place your ruler very close to the spring, close to the spring. Rule or ruler doesn't matter, it's the same. Okay, so I want you, if let's say this kind of question, sometimes 1 mark, sometimes 2 mark. 2 mark among these 3 points. Okay, number 2, use set square. Number 2, use set square as horizontal reference. Okay. Is it okay? Can we proceed? A little bit more. No problems, Crystal. Take your time. Okay, there is one drawing way by my students. They might be drawing this. Do you think that you can score the mark? Put your square like this. Do you think that you can get the mark? What do you think? Put your set square like this. Do you able to get the mark? Where I need to measure? I want to measure from here, the new length. I want to measure this. So if you put like this, it doesn't help me anything. You get what I mean? You need to make sure your set square, the horizontal part, is as the horizontal reference. Is it okay? Can we proceed? Crystal, done? Yeah, okay. Others, is it okay? Emily and Angeline, Crystal, okay already. Megan, okay. Huy Thong, okay. Okay, then we proceed. Okay, this one is another diagram. Okay, you remember these two part we are not going to make because these two part they didn't stretch. Okay, they cannot stretch. The extent part actually is the springs. Always measure below this part. Okay, until here. Okay, here measure the unstretched length. Unstretched length that means that without any load. Okay, can you measure? Because we put the load on the bench at here, that means that the spring actually right now didn't experience any force. Okay, measure it. No leh, Zihua. Your paper got problem Angeline, correct. I think Crystal, you can't get because if your printing scale is wrong, then you cannot get. You just write the tone. Emily, you measure and then tell me what is your unstretched length. How about others? Hui Tong, measure and then tell me. Be careful, here is mm. So what we measure in our ruler is in cm. So you have to convert and be careful. Okay, Hui Tong correct. Megan correct. Okay, answer is 55 mm. 5.5 cm actually is 55 mm. Okay. A student hang the spring on the force meter. Okay, this one is force meter. Okay, or we call it a spring balance. Okay, with the load attached to the bottom as the figure 5.1, the load remains on the bench. He gently raised the force meter until it reached 1 meter. Okay, hanging and then until it's reading at 1. Then what? He measured the new length L of the spring. So that means that hang with 1 Newton, then he measured the new length. Repeat the procedure using a range of force meter reading. The reading will be recorded on the table 5.1. Okay, so in this experiment, he repeat the experiment by hanging with 1 Newton. That means the load is 1 Newton. Then this is the new length. Then after that, repeat 2 Newton, 3 Newton, 4 Newton, and 5 Newton. Okay, next, calculate the extension for each set of reading using the equation. So at here, this one, this is the equation. You see, paper 6, they will tell you everything. You just follow and be careful with all the technique. Okay, don't simply skip any sentence. Okay. Then here, E equals to L minus O. What is your LO, teacher? Here didn't have any LO. It must be provided to you or they ask you before that. So at here, this is our LO, 55. 55 is our LO. So come here. E equals to L minus LO. So this one, how we do calculation? E equals to L minus LO. Okay, dear, can you do calculation and then you type your answer for me for the phi data? How you get it? How you find the extension? Very good, Angeline. Okay, remember LO is a constant value, unstretched length. Just now we calculate 55. So this one L is 67 minus 55. Of course, exam you no need to write. Okay, right now I write is because I want to tell you. So this answer should be 12. Then this one 77 minus 55, you should get 22. Then continue 36, 50, and 60. Okay, do you able to get this answer? Yes or no? Know how to do calculation, huh? The L is this L. All this value is your L. Then 55 is the constant value that you measure just now, 55 mm. Okay, is that clear? Now I'm going to teach you how to plot graph, how to plot the graph. Okay, let me check. If not mistaken, I got provided the technique to plotting the graph. Okay, can we go to your page number 8? We go to page number 8. I teach you how to plot graph in IGCSE. Okay, you look at the page number 8. This is the example. Okay, here plotting the graph of what against what. Actually, IG they're very kind. They tell you what you need to label in the y-axis against x-axis. So first, how we draw? Label the x-axis and y-axis. When you label, please label physical quantity, can be in words or in symbol, and unit. If you hear, let's say this question is E extension in mm is y-axis. So at here, I will write E mm, or I will write at here E mm. Okay. Then here F slash N. Physical quantity, this is the unit for force. If you only write E, F, then there is no mark, zero mark. Okay? As long as you write this at here, you score 1 mark for paper 6 already. So this is the first point. Okay, second point, we need to label the scale. This is the scale. Okay, this is the scale. We need to label the scale, and the scale must be suitable. Okay, so how I consider a suitable and easy plotting scale? Okay, I want you have the habit, which is like this. When you count for the 10 boxes, small boxes, actually this is roughly in the exam will be 2 cm. Okay, it will be 2 cm. This one is 2 cm. Okay, every 10 box you label like this. Okay, every 10, then we label, we draw the line. Okay, we are going to label at here. Okay, we are going to label at here. So at here, every 2 cm, the value that I accept is 1, 2, or 5, or multiple of them. What does it mean? Meaning that it can be 1, let's say this is 0 to 1, then continue add on 1, become 2, add on 1, become 3, add on 1, become 4. Okay, or 0, 10, 20, 30, 40, or 0, 0 0.1, 0 0.2, 0 0.3, like this. Okay, so at here, this is 2 cm for 1 unit lah. Okay, and there are multiples. Okay, this one is 2 cm for 2 unit. So 0, 2, 4, 6, 0, 20, 40, 60. Okay, this one is 5 unit. So 0, 5, 10, 0, 50, 100. Okay, avoid this kind of unit. 3, 6, 8, or 4 unit. All these are not a good idea. You will find out that you are very hard to find the point. Okay, so I will encourage you 1, 2, or 5. This is the best scale. Okay, then after that, the scale that you choose, must be make sure at the end your graph actually is more than 50% of the line. The line, okay, that means that like this, this is my graph paper. If your graph is like this, it's less than half. So this scale, that means that your scale is very poor scale. You need to enlarge it until it's more than 50, at least more than 50. So somewhere here, okay, it's fine. Somewhere here, okay, it's fine. Somewhere here, okay, it's fine. Okay, so you need to choose a correct scale so that at the end your line graph actually is more than 50% of your graph paper. Okay, then we will check the 5 point, whether you plot at the correct position or not. And then the last one, we will check 4 marks for your graph. 1, 2, 3, and 4. Okay, last mark is we will check, okay, whether your graph line actually is a best fit line or not. How we consider best fit line? If let's say all the point touching, that one is perfect. Okay, of course this one is perfect. Okay, it might be not touching all. If not touching all, then we try lah. Okay, we try to find the line, okay, and balance it. For example, this one like this, here like this, here like this. So can you see that this one I consider also good because one up, one down. This is balance. So this is balance. Okay, balance graph. If your graph is like that, like this. So your last point, best fit line graph, okay, you will be deducted. Okay, this one no. No. Okay, because unbalanced. Both not touching to your line, the 2 point at here actually is above. Okay, they are not balanced, one up, one down. Okay, so this is the 4 point how we get the how we plotting the correct graph. Okay, so with this knowledge, let me have a look. Okay, here you see this one is consider, but this one, this patch I get from the Malaysia government syllabus. Okay, if really cannot, then two up, one up, two down, one up, two up, one down also can. Okay, most important, trying to balance. It's not like all is at the bottom or is at the upper part. Okay, so this one also consider nice. You see this one is not, you not fully utilize. Your graph line is too small. You only utilize somewhere here only for your x-axis. So that means this scale is not good. Okay, then we are not touching drawing like this. I know that maybe some biology or chemistry, their graph maybe connect from point to point, but physics no. Okay. Then after that, here is some example you can go through. Okay, this one, you see, this is what I say. This one is odd number, the scale is not good. Okay, and then some more, this one, 1, 2, 3. 3 point not touching, and this 3 point is below the line. Okay, it's below the line. And then here, what else? Okay, some of my students, they will make mistake is, they draw the straight line, but they stop at here. Please make sure you are touching to the axis. Either touching to your y-axis or either touching to your x-axis, or they are starting from the 0, also no problems. Okay, so this is all the techniques. Okay, we can come back to our graph at here. We're trying to plot. Okay, so first we need to draw this line. Okay, draw this. Draw x-axis and y-axis. Okay, x-axis, they tell you already, E/mm. Okay, so we write E/mm. Okay, x-axis F/n. Okay, then after that, next step, like this, you already score 1 mark for the, 5 mark at here. Okay, 5 mark. Okay, that means that maybe the point there, they give you extra 1 more mark. Here, continue, scale. So we look at your x-axis first. We look at the force. So force at here, maximum value is 5. What do you think? What is the scales that I should give? Here is 0. What should I give the scales so that I can fit the 5 Newton? Okay, any of you can suggest a suitable scales for me? Okay, Crystal, nice. Okay, Crystal say we can choose 1.0, 2.0, 3.0, 4.0, 5.0, 6.0. Nice. Okay, so this one you see, we use more than half. Maximum value somewhere here, okay? And after that, look at here, maximum is 60. Can any of you suggest to me what is the scales, suitable scales for us? Let me check. Angel, correct? Y10 correct, nice. Okay, so at correct, we choose 10, 20, 30, 40, 50, 60. Okay, like this, you score second mark already. Okay, then next, plotting the 5 point. Okay, guys, you plot by yourself, then I plotting here. Later on, we check our answer together. You plot. So first one, 1 Newton is 12. So it's 22. 3, 36. 4 is 50. Then 60. Okay. Okay, from here, I want you try to draw the best fit line. If all the 5 points you plotting together, here got 5 marks. That means that plotting for the point, they give extra 1 mark. So 2 marks at here. If you plot correctly, then you get 2 marks. Are you guys in this step already? Same as me? Okay, plot your best fit line. This is my best fit line, dear. This is my best fit line. Okay, not all the point is touching on the line, but it's still considered best fit line. It's because I got 1 point above the line, 1 point below the line. So actually, this line is balanced, it's best fit line. Okay, be careful. Sometimes students, they like to have something like this. They draw halfway, feel like, not really good. Can I slightly change a little bit? Then they redraw, continue drawing. But they didn't, they overlap, sometimes here they overlap something like this. So here slightly thicker, actually we can know, like this we will consider your best fit line is not a smooth and continuous. Okay, the keyword at here, smooth and continuous line. One shot, if you found out that you draw half wave, then not that good, then you erase all. If you erase all, actually, just now, all this point is already plotting, or although you erase, but we still can find out easily because you got plotting just before that. So you can erase all. Then after that, replot the point, redraw the line. Do not trying to continue again. Okay, like this, we found out that the thickness is different. That means that you have redrawing at some way there, overlapping. This is not considered a smooth line. And then thin, keyword thin. So please using sharp pencil. All drawing using pencil, dear. All drawing using pencil. Okay, like this, we score 5 marks. So from here, did you able to get the idea about how we getting the graph marks from the paper 6? Is it clear for you? What is the technique for us to plot graph? Is that clear? Or you still plotting? Huy Thông, okay. Crystal, okay. Megan, okay. Angeline, okay. Okay, then we goes to the last page. Determine gradient. Okay, highlight gradient. Okay, show clearly on the graph. Show. How you show, teacher? Gradient, please show by drawing. Draw a big triangle. Okay, my student always mentioning big, big, big. At the end, they still give me a small triangle. The big triangle gradient, can I take the value for the whole graph? You means that from where to where? Okay, if let's say, Angeline, let's say the last point at here is exactly on the line. You want to take this point and then draw this as your triangle? Yes. Or you want to drag this one and here? Is because I say yes also is because this point, the first point is also on the line. If the point is not on the line, you cannot take the point. We must find the point on the line. Okay, let's say this point. Teacher, can I use this point as my triangle? No, because this point is not touching. If you want to using this point, you must find some way that easy for you to read. For example, this point, easy for you to read. You see this one exactly at here. If you choose somewhere here in the halfway one, we don't want to using this kind of point. If you want to use this point, is it okay? Yes. You can also using this until your last point as your triangle. Yes. Triangle must be as big as possible. Okay, they got requirement. So for me, I want to encourage my student at least like 4 to 4 lah, at least 4 to 4. So 4 to 4 somewhere one. Okay, wait. 4 to 4 is 4 to 4. Some big like 1, 2, 3, 4. Yeah. Some big like this. Okay. The size something like this. Okay, so for me, I will trying to choose the point which is nearer to the end. Since this point is so nice, it's just on the line, so we can using this point. Since the graph is touching to 0, so I can using this point. So for me, okay, I will, okay, let's say from here, okay, I will use this point. Oh, I'm so hard to draw. Well, let me move. Okay, I will use, because you see, if I draw like this, we cannot see, right? So I will slightly draw out a little bit of the line, something like this. You need to make sure your examiner can see your triangle. Okay, then after that, from here, I also do the same thing. Well, okay, let's say it's here. Okay, if I put exactly on the line, we cannot see, cannot see. So please, girls, boys and girls, you slightly move up a bit. The dotted point, slightly above. Okay, like this. Slightly above, something like this. Okay. Then after that, in order to make sure the examiner can see clearly, I will do like this. I will do like this. Draw a right angle to tell the examiner my triangle is here. My triangle is here. Then I will label the point. So this is 5.0, then 60. Here is 0, 0. I label with the point, although this is no extra mark, but I tell examiner this is my triangle and this is the point that I use to calculate my gradient. Okay, so please, this one is x1, y1. Here is x2, y2. So this one, F Newton is actually your x-axis. E/mm actually is your y-axis. Unit, must have the unit. Do your calculation for the gradient. Gradient G is, okay, here I write in more clear lah. Exam you no need to write like this because I worry this is the first time we do calculation. So I tell you y2 minus y1 divided by x2 minus x1. So comes to here, y2 is 60 minus 0. X2 is, let me have a look. X2 is 5 minus 0. So my answer at here will get 12. What is my unit for gradient? What do you think? You need to have unit all the time. E/n, no, wrong. Emily, also wrong. What is the unit for y-axis? What is the unit for x-axis? No, Zihua, what is your unit for y-axis? What is the unit for x-axis? Why it start from 0, 0? Crystal, you means that why my triangle start from 0, 0? Is it? You can start from here also, never mind. As long as your triangle is big enough. I start from 0, 0 is more easier to do calculation and the triangle is big enough. Okay, let me have a look. Hui-Tong correct. Angeline correct. Okay, Zihua correct. Right, dear? Y-axis is mm. X-axis is in Newton. So it should be here mm per Newton. Mm per Newton. Mm per Newton. Okay, so paper 6, I choose 2 questions and teach you some technique. Okay, so it's not hard. Paper 6 is not hard. You just follow everything and you do not trying to skip any sentence. Okay, this is a common mistake done by my students. They like to skip and then they trying the keyword. Oh, gradient. Then sometimes they will miss some important information and some of the question they didn't answer. Okay, so don't forget about the unit. Be careful with the unit when you do measurement. And then how we score the marks for your graph. Actually, it's bonus mark if you know the technique. Okay, so and follow step by step. All the what I say, all the calculation they want, actually they will tell you one. They will tell you the formula. You see, extension, what is the K? All they provided. Okay, they provided E equals to L minus LO. Fine. What is your L? What is your LO? And then K, F over E. Force divided by E. Okay, if no question, we are going to the lesson number 16, worksheet. Is it okay? Any question you want to ask me about paper 6? No, Angeline, okay? Okay. Lesson number 6 actually is very easy. I know that year 9 you learn about this pressure in solid. Okay. Here pressure is perpendicular force acting to the surface per unit area. Per unit area A. Okay. So at here write down P equals to F over A. But at here, I want to emphasize the force. Sometimes they don't directly give you the force, but they give you mass. Then from the mass, how do I relate with the force? We can using the formula, force actually can be the weight of the load. Force can be the weight. So we can force using mg. W equals to mg. So in order to find the force, we can finding mg. Okay, if they didn't give you the force, then they give you the mass, then we have to apply mg to find the force. And then what is the g? 9.8 Newton per kg. The value they won't tell you and you have to know by yourself. Okay, so at here, what is the unit for the pressure? Okay, pressure is force divided by area. Can you tell me what is the unit for pressure? I need to train you. If we didn't memorize the unit, but we also can answer the unit. Angeline, correct. This is the SI unit called Pascal. If based on formula, then how you know the unit? Let's say you forget Pascal. So how you know the unit for pressure? Pascal, yes, Zihua. But if let's say we forget about Pascal, from the formula, how do I know? Crystal, no. What is the unit for area? So Angeline, which one is your answer? Newton per meter square or Newton per meter cube? Emily, no. Crystal, correct. Okay, Angeline, correct right now. Emily, correct. Okay, deal. Correct, Zihua. Okay, dear. Area. Area is cm square or meter square. This is area. Volume only cube. Okay, so if let's say I want force is in Newton. So our unit can be Newton per meter square or it can be Newton per cm square. But this one is SI unit. So Pascal actually is Newton per meter square. Pascal is Newton per meter square. When I say 1 Pascal, actually it's 1 Newton per meter square. If the question doesn't specific to SI unit, then you're just using Newton per cm square. Is that clear? Okay. So boys and girls here, I know you guys are very smart, but I want you, when we do worksheet, you always practice to write formula. The more you practice to write it down, I know it's easy right now because we are learning right now. But if you write more, actually it will go into your brain and then this formula will stick together with you. Okay? So the force. The weight is 200 Newton. So this is a force in Newton, you see. So 200 divided by area. Which one is our area, dear? Which area is the area that you want to find? Which area? Let me check. Correct, Emily. Okay, Angeline, correct. Crystal, correct. Okay, dear. I want you emphasize this is the area. The area touching to your table or touching to your ground. This is the area that we want to count. Okay. So this one, if based on the diagram, 1 meter, here 1 meter. So it's 1 meter times 1 meter. This is in Newton. So our answer is should be 200 Newton per meter square. Or you can say 200 Pascal because this is SI unit. This is SI unit. So your answer can be writing in Pascal, Pascal or Newton per meter square. Okay, next, B at here. Do your calculation right now. I'm also doing. Where is your area? Okay, so this is the area that we want to find. So it should be 2 meter times 1 meter. So my answer is 100 Newton per meter square. Let me check. Emily, correct. Zihua, correct. Okay, so dear, can you see that? This one, your area actually is increased. Your pressure compared to just now the case is decreased. The larger the area, the smaller the pressure. Smaller the surface area, the larger the pressure. Okay, is that clear? Can we proceed? Is it okay? Yes, Crystal okay. How about others? Xuan, is it okay? Megan okay. Angeline okay. Xuan okay. Okay, dear, go. Just now is compare same weight, same object, is same weight. Okay, now we compare different force, different weight, but using the same area. Okay, this one is same area. So P equals to F over A. The force is 50 Newton divided by area is 2 meter square. Okay, this one is P equals to F over A. 100 Newton divided by area is 2. Okay, so at here, your answer here, 25 Pascal or Newton per meter square. This one is 50 Newton per meter square. Okay, can you see that when your force increase, force is 100 Newton is force increase. Your pressure actually is increase also. Okay, the more heavier acting on the table, actually the more pressure is exerted. Okay, so the greater the force, the greater the pressure. So you see, P equals to F over A. I want you to be very clear, relationship. P and F, what is their relationship? They are directly proportional. What is the meaning of directly proportional? Is pressure increase when your force increase. This is called directly proportional. Directly proportional. Okay? If let's say today the question is asking you about the graph, how was your graph showing directly proportional? So this is pressure, this is force. It should be like this. Pressure in Pascal, then force in Newton. So their relationship for the force and pressure is called directly proportional. You increase, I also increase. Okay, so this one side by side, you see, if this value is a big value, of course, final answer will be a big value. Okay, here area. What is the relationship between pressure and area? Okay, their relationship, their relationship is called inversely proportional. Okay, what does it mean inversely proportional? Meaning that when your area increase, pressure decrease. The greater the area, actually the pressure that we experience will be smaller. So you imagine, girls, if we wear sports shoe, we can run in the field. Okay, sports shoe, we can run in the field. It's because the sports shoe actually is the largest surface area, so small pressure acting on the field. Okay, but if let's say today you wear high heel shoes, okay, high heel shoes, so the surface area becomes smaller. So when you step in the field, on the field, actually you will sink. It's because the pressure area decrease, your pressure increase. So your high heel part actually will sink into the field. Okay. So at here, pressure and area, they are inversely proportional. If let's say plot graph, how was their relationship? Okay, this is pressure in Pascal. So this is area in meter square. So this one like this. Okay, is that clear? Angeline, hey. Okay, so 2003, first question, you do calculation. This is quite straightforward. I want to practice, write formula, substitution, final answer. I know that now you got calculator. Actually, you press, you already get the answer for MCQ. Always my student asking, teacher, this is MCQ, why I need to write working step? Working step right now, we are practice. We want to make sure no matter today is MCQ or structure question, you also have the habit write formula, substitution, and final answer. In your exam MCQ, you don't need to write, doesn't matter. But we right now is practicing, okay? Practicing, we having the habit. Actually, in MCQ, I also encourage you to write. So when you complete whole exam paper, when you come back, you want to do checking. Actually, it's more easier for you to identify whether you got do substitution value wrongly or not. Okay? Angeline, correct. Hui Tong, correct. Answer should be C. Just using 600 divided by 0.05. Okay, P equals to F over A. Practicing formula substitution. Final answer with unit. Now it's practice. Okay, although this is MCQ. Okay, next. And you guys try what pressure at the base of the block due to the weight. Angeline, correct. How about others? Zihua, correct. Emily, correct. This question also they didn't like trick you lah. Nothing to trick you. Okay, so at here, like this, like this, like this. Okay, basically, this one is the area. This is the area. So area is 4 cm and then here is 5 cm. So you should be 4 cm times 5 cm. Be careful, this is cm. So your final answer should be Newton per cm square. Newton per cm square. Okay, your answer normally you write 0.8. Okay, I will tell you that in structure, better don't leave your answer at 0.8 because this is only one significant figure. Please add a zero. You see final answer here 0.80, two significant figure. If the examiner is very strict, then they can deduct your mark 0.8. Is that clear? Although 0.8 and 0.80 is the same, what teacher? Significant difference. A significant figure is not the same. Okay, is that clear? Okay, we proceed to the next page. Question number 3. Okay, can you try? Hui Tong, correct. If you cannot get answer, meanings that maybe your mathematics is not strong. You don't know how to move what the value divided by what. Okay, so at here, your answer should be 14 divided by 25. It should be 0.56. Okay, if let's say this is not MCQ, you have to think what is this unit? How I know? Newton per mm squared. So this is mm squared. You don't just write m square, have to be careful and check. Okay, you all are answering correct. So answer is A. Okay, we go to the next question, number 4, 2023. Okay, do it right now and then tell me. And Crystal, no. Crystal, no. Angeline, correct. Emily, no. We Tong, no. Cute. Highlight cute. Their side are the same. So here 0.5 m, 0.5 m, here also 0.5 m. So if we draw it out, which area we use? It should be here. Okay, pressure equals to force divided by area. Can you see that? This is what I told you. They give you in mass. They are not giving you in force. So how do I know what is the force? due to the load at here. Okay, so this one, please remember mg, change to mg, because W equals to mg. The weight actually is a force. Weight is a force divided by area. Your mass is 120 times 9.8 divided by area. Area is the part touching to your ground. Okay, so it should be 0.5 times 0.5. Emily, correct. So my answer here, 4704 Newton per meter square. This is from my calculator. But why answer is C, 4700, not 4704? Is because as you, they want 2 to 3. If let's say 2, zero go in, so no need to add extra credit 1 to the 7, okay? If 3 significant figure, 4 less than 5, so we also no need to add 1, okay? So if add 1, it will be 7, 1. But here right now, the 4 is less than, so no need to add 1. So our answer is 4700. Is that clear? Angeline, so what is your answer? Okay, next question is, on which face must the box raise to exert the least pressure? Smallest pressure. Ask yourself, when smallest pressure, which face you need to put? Emily, correct. Angeline, correct. Okay, P equal to F over A. I want small pressure. What happened to my area? Area must be big. Okay, you need to wear shoe. It's not wear the high heel shoe. Okay, so at here, teacher, why we not consider about the force? The force at here is the same. Why the force is the same? Because the box, no matter how you place, the mass of the box is the same. Okay, same object, same mass. You didn't change about the force. So we only study about relationship between the area and pressure. Okay, so the largest area it should be face X. Answer is A. Phi A. Is that clear? Is that clear? Can we proceed? Okay, next. Right there, number 6. Okay, A, B, C, D. Which one will cause the greatest pressure? Emily, correct. Zihua, correct. So, smallest area lah. Answer is B. Okay, answer is B. Okay, which block exert the greater pressure on the surface below? Crystal. Your Crystal, your answer is for the question 6. So do you get the idea why question 6 is B? Crystal, do you get the idea why the question 6 is B? Yes. Okay, then Crystal 7, try. Angeline, correct. Okay, how about others? Question 7. Which block will exert the greatest pressure? Correct, Crystal, correct. Greatest pressure, that means that we got two things have to think. E equals to F over A. We got two things have to think. If you want pressure greater, 1, your force should be higher. Number 2, your area should be smaller. Higher pressure, a higher force, yes, C or D. So answer. Then smaller area, C. Okay. Do you know that the Malaysia road always like got holes one? That is because the lorry, we got too many lorry on the road. They having a high weight, high mass, high weight. So it will create a high pressure on the road. Okay? That's why how to reduce. But teacher, the lorry is so important, carry so many things or transportation or for whatever. Okay, so since the weight is high, it will spoil or damage our road. Then how we reduce the pressure? Leh? Okay, that's why you observe the lorry actually they got a lot of tire. For the car, we only got 4. But for the lorry, they got more than that. So they're trying to using a larger surface area, although the force is increased, but they're using largest area to reduce back the pressure. So that the lorry won't be so easily to damage our road in Malaysia. Is that clear? Do you able to relate pressure in our life? Yes or no, dear? No response. My example about the lorry, do you get the idea about pressure? Yes or no? Number 8, T-shape. Okay, this object T-shape is placed on the ground in position X. Okay, then it turn over to position Y. It become like this position Y. Same object is same object. It's because it said that starting in this position, after that in this position. Okay, what happened to the force and what happened to your pressure? Let me check. Emily correct, Angeline correct. Okay, so at here, since they are the same object, you are not object A and object B. From starting to ending, we are using the same object, just placing position only. So the same object, actually the force will remain the same. Okay, the force will remain the same. And then this one, the is so small, only this part is the area. Only this part is the area. Okay, so this part, area decrease, pressure higher. So answer will be C. Okay, we go to your next page, page 5. Drawing pin, sharp point and flat point. N. Okay, can you tell me A, B, C, D? What happened to the force at sharp point? What happened to the pressure at sharp point? Teacher, can you back a bit? Yes, dear. Coming here. Okay, let me check the answer for the Emily, correct? Angeline, correct? Crystal, correct? Okay, Shun already done, Okay, dear. Oh, not bad, you guys' understanding is good. Answer will be C. The force will be the same. Why the force is the same? Okay, dear, I want you, look at me, I want you holding your pencil. One side actually is the sharp point, your pencil, then another part actually is flat end, okay? So I want you using your 2 forefinger holding like this, and then you press. You pressing. Apply the force pressing. Can you tell me both finger, do you having the same feeling? Or actually one of the side you will feel more pain? Holding your finger, you look at me, Newton scholar here. Holding your pencil, one side is the tip, okay, the sharp point. Another part is the flat point. Using forefinger, you press, and then you tell me, is it both finger you having the same feeling, or actually one of the side is having more pain feel? Okay, the feeling is more pain. So can you tell me which part? If you feel pain, then which part is getting the feeling? With the flat or with the sharp point? Any of you? Have you guys tried? Let me have a look, Crystal. With the sharp end, right? You will feel pain. Why feel pain? It's because the pressure is high. Pressure is high, actually you feel pain, high pressure. Or we saw the keyword sink. Okay, all this is because high pressure, so high pressure. Okay, why I say the force is the same? Because you're using your forefinger, you apply the force. Actually, both ends, they gains the same force, okay, same force. If you're getting different force, then it will go to one side, okay? So at here, the force that experienced by both way, because we apply the same force, one force here, okay? So the force is the same, then the pressure is getting bigger, okay? With this point, you feel pain is because high pressure. Okay, we go to the 10. More likely to sink Just now I told you, if you feel pen or you found the keyword of sink, meanings what? Okay, so 10 X and Y, which one will more likely to sink? Answer, Krista, A, B, C, D. Angeline, correct. Krista? What the is the Okay, Emily, correct. Krista, correct. Okay, answer is A. So this one will sink. More likely to sink is because surface area is small, pressure is high. Okay, compared to this. Okay. I think the boy Y actually I think the boy Y using recycle badminton. Okay, Lydia goes to your next. Okay, page question 11, figure 4.1. A student standing on sand does not sink. Does not sink, that means that the pressure is low lah. It doesn't sink. The student have the mass of 40 kg. What is the force of her body acting on the sand? How you find the force of the girls? My boys and girls, calculate and then tell me. Angeline, very good. Force related with the weight, mass, actually we can calculate the weight. W equals to mg. 49.8. So your answer should be 392. What is the unit? Newton, because this is a force. Weight is one type of force. Crystal, correct. 392. Or your answer in 390 also can. But because this value we are going to bring forward, so put three significant figure. Okay? 392. Capital letter N. Okay, here, total pressure, total area of both shoes contact is 0.02 meter square. Calculate the pressure the student exerted on the sand when standing as shown in figure 4.1. Okay, this is total area. They already told you total area. Some of the question, they like to trick you. They will tell you that, hey, the area for one shoes is 0.01. Then you have to know you got two shoes times 2. So you need to read the question carefully. It's not saw the value, then you apply only. No, you have to digest and think. Should I times 2 or not? Okay, so P equals to F over A. The force, you already get it. 392 divided by area, 0.02. So your answer, my answer, let me check. Emily answer, is it correct? Yes. Okay, 19600 Newton per meter square. Because this is Newton, this is meter square. So 19600 Newton per meter square. Three significant figure. 1, 2, 3. Three significant figure. Okay, the student leave one foot off the sand. The other foot will sink. If only one foot, then it will sink. Explain why this happened. No need to do calculation. Of course, if you don't know, then you do calculation. Crystal, correct. Okay. Zihua, correct. Okay, here, why this happened? Is sink is because high pressure. Why high pressure? Is because smaller surface area. Okay, so greater is because greater pressure. Then explain why. Okay, here, if let's say some here they give 3 marks. If they give 3 marks, if 2 marks easy, same greater pressure, then talking about the area smaller due to the smaller area, due to the smaller area. Okay, so like this, 1 mark, 2 mark. But sometimes the question will give to 3 mark. Where is the third point? 1, 2, 3. Pressure is force divided by area. You already talked about the area and pressure. Then we can talk about the force. With two foot with two standing with two actually you are having same weight what, right? No matter how you stand, whether you live or not living, so your mass is also the same 40 kg. Your weight is the same 392. So at here number third we can talk about the force. So what happened to your force? Same force or same weight acting. About the force. Same weight or same force acting on the sand. 3 marks. Okay, is that clear? Horse area is less area above foot. Yes, correct. But if they got 3 mark, we talk one more point talking about the force. Okay? So next page. A man squeezed a pen between his thumb and finger. The finger exerts a force 40 Newton. Area is 6 times 10 power of -5. Pressure acting by the finger on the pinhead. This is pinhead, okay? Pinhead. Pinhead is here. Okay, so pressure equals to force divided by area. So what is your force? 84 Newton. Then area is 6.0 times 10 power of -5. Okay, then after that, if you do calculation, for my answer here, I record is 2 single lah. Okay, I will get Newton per meter square. Be careful, here is meter, here is Newton. Or I can say that 1400000 Pascal also no problem. Okay? So Angeline, let me check. 1.4 times 10 power of 6. Yes. Okay, you want to write in can? Or you leave at like this, also no problems. So your friends Angeline say 1.4 times 10 power of 6 Newton per meter square, also correct. Okay. State the value of the force exerted by the pin on the thumb. So just now at here, let me have a look. Finger force is 84. How about your thumb? What force your thumb experience? 84 Newton also. Correct. Zihua correct. So at here, 84 Newton. Same force. Okay. So just now this question is the same thing what? Okay. Drawing pin. So the drawing pin, what happened to the force at the sharp point compared to the flat end? Actually, they are the same. Okay, same force. Then after that, come back here. Explain why the pin cause more pain, dear. See the keyword that I told you. Why more pain? Because higher pressure. Higher pressure. Okay, let's say this is 2 mark. Okay, higher pressure due to smaller area. Acting on thumb. Okay, 2 marks. High pressure, smallest area or smaller surface area. Okay, is that clear? If 3 mark, same force action, but higher pressure is because smaller area. You talk about this physical quantity. Okay, until here, is that clear? Can we go to the last page? No response. Okay, Megan, okay. Okay, Zihua, okay. Good job. Okay, dear, here, how we relate physics in with our life. My student always say, teacher, why we need to learn physics? No, we are not using in our life. No, we are using physics in our life every day, okay? You use it, but you don't know. Okay, the knife at here is better cutting is because here, small surface sharp. Sharp is small surface area, then you will produce a high pressure. That's why you can cut easily. Okay? Zihua say we learn physics because teacher and professor wanted to torture us. Hey dear, you can my school, they can choose that. If they're really not good in physics and they don't want to learn, actually they can choose other subject like choose economic, business, tourism, and so on. Okay. So don't say that we want to. Okay, right there. Pin, drawing pin. How we put, why we push and then at the end it will go in. Okay. Time is spread out the over the head of the pin so that spread out. Why this part we need like a bigger surface area is because we want lower pressure. Okay, here we want lower pressure, same force. However, at the sharp point at here, we will get a higher pressure. That's why it will force the pin go in, higher pressure, so it go in. Okay, this is application if we want high pressure. Then we're trying to make the device or whatever become smaller surface area. Then sometimes we want the pressure, sometimes we don't want. For example, at a soft ground, okay, the wheel barrel at here, we want to go, but this tire is so small surface area, it will cause a problem and it will sink. Okay, sink. We should increase the surface area. So you see they are so smart. They increase the surface area touching with the soft ground. Okay, so at here the pressure exerted will. Okay, camel. Emma, if year 9 you learn about science, I'm not sure in under what chapter, but adaptation. Why camel can be survive, adapt to the environment. They got wide feet, okay, larger feet. Okay? It's because their mass is very big. Their weight is larger weight. Okay, they will spread out with a larger area when wide feet. Okay, so the pressure will be lower or low and they will not sink. We don't want the camel sink into descent. So they are automatic in order to survive after what we say evolutions. So they're having this adaptation. Okay, so basically we already done our worksheet 16. Next week we'll continue 17. And I will prepare the next chapter because the left the pressure in liquid, then done, we will continue with new chapter. So next week I will prepare new chapter in case we finish early, then we can the new chapter, chapter 6. Okay, until here, any question, dear? Let me check Crystal. Teacher. Okay.